Hey everybody. If you don't know me, my name's Alex Parker. I'm a product manager here at Replicated, mostly working on our installers these days. And so today I'm going to give an update and talk a little bit about the roadmap for the Replicated installers. And if you were at our last RepliCon or maybe watched the talks afterwards on YouTube, I had a talk talking about what's next for Replicated installers. So this talk will be an extension of that talk. And to start, I'll briefly recap some of the things that we talked about last quarter. We presented Embedded Cluster version 3, so this is our upcoming major release of Embedded Cluster 3.x. And looking at the spectrum of installers that Replicated supports, we have on the left side more user control, your customers fully in control of the install. So in the extreme side, that would be true Helm install, where they take your Helm charts and install them, all the way to the right where we have our more turnkey solutions, which is where Embedded Cluster would live. And so Embedded Cluster is a way to deliver your application and infrastructure as an appliance to enterprise Linux machines. So it's that real turnkey solution with a GUI for installing and upgrading and other ongoing operations. So you get a config screen to get their input, runs pre-flight checks. In the field, we've seen over 95% install success rate with embedded clusters, so it's very successful at installing into enterprise environments thanks to things like extensive host pre-flight checks that run before install and give actionable instructions if any of those pre-flights fail so that you can rectify those problems before moving forward with the install. But in V3, we've made a lot of different improvements that I'll touch on briefly here. So we have a really complete UI experience now in V3. The full install happens in the UI as opposed to previously where we had half of the install happening in the CLI and then partway through the install you would transition to the UI to finish it out. Now the whole thing can take place headlessly in the CLI, but can also happen fully in the UI for people that want that guided experience. And it makes it really easy to see host pre-flight failures, rerun those failures after you fix issues, and do things in the GUI instead of having to navigate the terminal output to figure out all of this stuff. We've also added in improved deployment visibility, so you can view logs live in the UI now, which is useful for seeing progress or for troubleshooting. There's overall just better progress indicators for what is being installed or upgraded, what stage of that process we're at. When it comes to your application, we actually show each Helm chart as it's being deployed incrementally. So again, just giving better indications of what is being deployed and where we're at in that process. We've also taken out a lot of proprietary install logic that we had been using before through COTS. And so in this case, we're really just installing Helm charts. There's not any complex version rendering like previous versions of Embedded Cluster had. We're not deploying an object store or a database for storing anything. We're really just storing some things in cluster or on the host for easy access. And this makes that install and upgrade process really straightforward and simple for us to orchestrate. And then briefly on upgrade, we've integrated with the enterprise portal. So now that's the place that you go to learn about newly available versions. You can get email updates when new versions are available. If your customer wants to know if there's a new version of their software, they can subscribe to updates in the enterprise portal to get notified about that. And it also makes our install and upgrade experience identical now. So you go to Enterprise Portal and then you download things and you go through the UI to install. And the same thing is now true for upgrade. You go to the Enterprise Portal, download the assets, and then go through the UI experience to upgrade. And this has also made our upgrades a lot more resilient because now we're running both the upgrade process and the UI on the host instead of inside of a pod in the cluster. So this mitigates a lot of problems we saw in the past, like the UI losing connectivity halfway through the upgrade because the node had to be drained. And we're also able to run host pre-flights for upgrades now, so we can catch issues not just before install, but also before upgrade. Moving forward onto since that last talk, what have we been working on since then? And while there's been a lot of different things that we've been working on, moving this new major version of Embedded Cluster forward, we're getting very close to general availability, which I'll talk about a little bit later. But the main thing that I want to demo today is multi-node installations and talk about how we've added multi-node into V3 that was not supported at the last RepliCon when I demoed. So I'll give a quick demo of this multi-node experience and talk about how some of the re-architecting and the user experience changes that we've made in V3 really facilitate the multi-node experience and making it more robust and easier to use and things like that. So the main improvement thus far that we've introduced in multi-node is making it easier to use. The join process for joining new nodes to the installation is significantly faster. We also have more opinionated cluster setups to help avoid issues, so ensuring that people end up with an appropriate cluster configuration deployed. You don't particularly want to have even numbers of controllers in a Kubernetes cluster or things like that. We're putting some of our opinions in there, and we're also planning to allow our customers to have their own opinions about what cluster setup should look like for different installations. And I'll talk about that a little bit more in a minute. And then also the join process now happens before anything else gets installed into the cluster. So in previous versions of embedded cluster, you went through a pretty good portion of the installation before joining nodes. And that actually led to some challenges because it was really because of COTS. It was because COTS was the UI that was guiding people through this whole process. And COTS ran in the cluster and needed storage for its database and things like that. So we had to set up a lot of infrastructure and a lot of things just to get the UI to show up in the first place. So to the point that I made earlier, by pulling the UI out of the cluster and running it separately, we're able to really streamline the whole rest of the process. And this is one example where we're now able to join nodes in the very beginning of the install before we've installed anything else. Because we actually, in previous versions of embedded cluster, let's say you were doing an air gap in multi-node high availability install, we would actually install the registry in a non-HA mode because we didn't know how many nodes you were going to add. And then when you added your second and third controller, we would migrate that installation to high availability. But that migration was unnecessary if we added the nodes first. This kind of reorienting of how this process works helps to simplify a lot of things and make it work a lot better. So let's go through a demo of some of this multi-node process just to be able to see what that looks like. So I've got here for this customer that I'm using, I have the multi-node cluster entitlement enabled. So if you don't have this enabled, then when you go through the install experience, it's going to be limited to a single node. So it's just going to progress from installing that first node right through to installing the application. But because I've got this checked here, I know that this is an install that supports multiple nodes. And so in the UI, I'm actually going to have the opportunity to add nodes. So I've already filled out my config screen, already set up my data directory and all the other stuff that happens on the setup page. And now we've installed our runtime on the first node. So the first node is set up. We ran our host pre-flight checks. And now I've got the opportunity to add additional nodes here. So right now, what's supported is a controller node or a worker node, and I can choose what I want to add. In this case, I'm going to make this a highly available cluster, so I'll install another controller node. And this is our join process here. So it's a little bit different than previous versions of embedded cluster for a couple reasons that I'll touch on. It's a little bit more manual to start right now. And this is for one of two reasons, but the main thing is that it's a little bit more manual because we're bringing a lot of this orchestration back to the host. So whereas in previous versions of embedded cluster, a lot of orchestration of the environment happened from pods that ran inside of the cluster, that's where a lot of the resiliency or reliability issues manifested. And so we're updating these processes to run more on the host. And we have the intent or the hope, depending on usage and feedback and things like that, to be able to automate more of this process. But we want to make sure that most of these cluster orchestration things originate on the host rather than pods in the cluster. So the join process here is that we're going to create a join bundle on the first node. And so that join bundle has the necessary information to be able to join additional nodes to that cluster. Things like the proxy information and the version and all that kind of stuff. We take that from the first node, copy it over to another node that we want to join, extract it, and then run that join process. So I've already gone ahead and done that on one node. I'll go ahead and do it on a third node to demonstrate. But I'll also point out that I'm not able to proceed right now from this page because I have two controller nodes. And it's not a good practice for a Kubernetes cluster to have two controller nodes. It really should be an odd number for quorum and reasons like that. And so we actually prohibit you from proceeding with a two controller node cluster because you should have one or you should have more than three at that point. This will also touch a little bit later on ways that we can leverage this mechanism to help vendors ensure that their customers end up with the correct cluster setup that they've intended for their application. Heading over to the terminal here, I have already generated that join bundle, copied it over here, and extracted it. So all I need to do here is run join, and it's going to use the cluster seed JSON that's here and some of the other information that was extracted from that tarball, and it's going to join this additional node to the cluster. And eventually that is going to pop up here, and we'll have a third node and we'll be able to continue. So you can see right now it's not ready. So I've got another verification here. All the nodes have to be ready and up to date before continuing. So once this node becomes available, that message will go away in just a sec and whatnot. So coming back, I'd like to show the upgrade process as well, but I'll come back while that's going and talk a little bit about the roadmap and some things that are coming up here. So beta and general availability are obviously two of the biggest milestones that we have upcoming here. This is coming by the end of March. So we're on a path right now to have the first release of Embedded Cluster v3 really ready for people to be using. We're putting those finishing touches on now, and then general availability is going to be determined based on customer integration and feedback. Probably a beta by the end of the month, and that will really allow a lot of customers to start trying this out, giving us feedback and finding any rough spots there so that we can get it ready for general availability. And as a part of that, we're also taking a look at customer requests. So what do you need? This new architecture that we've made for V3 has made a ton of requests that we've gotten easier and more feasible. That was actually a big driving force behind some of the changes that we've made here, is that there was features that made a lot of sense that we really wanted to support, but the architecture that we had was either made that infeasible or just made it really complex. As I've already mentioned in this talk, moving the UI out of the cluster and making it run standalone right from the beginning of the install unlocks a ton of capabilities that people had been requesting that were just difficult to support previously. So something we're planning to do is run through our backlog and just knock out as many customer requests as we can. We've really found that with this V3, we're able to iterate a lot faster. We're developing a lot more successfully than we were before. So we're looking to really show that and go through and knock out as much of the backlog of requests as we've gotten for Embedded Cluster as possible. And if you're someone that wants to partner with us as an early adopter of Embedded Cluster v3, we'll run through your requests in particular. We'll go to our shared GitHub repo and have an engineer run through your requests and see how many of those we can implement as quickly as possible while you're getting on board to Embedded Cluster. So we're really optimistic and positive about the experience that we've developed here and our ability to make further improvements to it. And so we'd love for you to come along and help us try that out as well. So I mentioned that this new architecture is a major unlock, and here's a couple of the ways that manifests. So one, we've already talked about, but the guided cluster setup. You can ensure that no customer proceeds with an incorrect setup again. So we've already seen how we're enforcing some of our standards here, but imagine if you had a multi-node scenario where you wanted to have 3 controller nodes and 3 dedicated storage nodes, and then maybe some number of worker nodes for the application stuff to run on, for example. You could create 3 different roles, a controller role, a storage role, and an application role, and say that this customer needs to have 3 controllers and 3 storage nodes and 3 database nodes or whatever it might be, and then 2 application nodes or something like that. And so that could be codified in your embedded cluster config so that when customers come through here, they have to get the right setup before they're able to proceed. And that'll eliminate the possibility of people being confused, proceeding prematurely or without the right nodes, and things like that. This has also made it possible for us to support not just headless installs, but also upgrades, and not just for single node, but also for multi-node. So in Embedded Cluster v2, only headless installs for single node are supported. Upgrades were not supported because it just didn't integrate well with COTS, and multi-node wasn't supported because when you went through the headless install, it went ahead and installed everything and didn't give you a chance to add nodes. So you'd have to add the nodes on later, and maybe your application install failed because it needed all of those nodes to be joined before the installation was going to succeed. So We've already got headless installs and upgrades working for single nodes. That's already a big improvement for people who want to test upgrades in their CI process, for example. And then we're also going to add a way to be able to join nodes as part of that process so that you can test an end-to-end multi-node install and upgrade headlessly, like in your test suite or things like that. Custom branding is something else that we intend to support. The UI has just been really modernized. We're using Tailwind CSS. There's been a lot of simplifications from the old COTS UI that makes it really easy for us to support custom branding. For example, this is the blue color scheme that you're familiar with from COTS, but obviously that doesn't match WordPress Enterprise. So we can go from this to this and have a much more branded look that fits with our company guidelines or things like that. Upgrade host preflights is something that we've already added, but also the ability to bring your own host preflights that can run both on install and upgrade to make sure that all of your host requirements are checked as early as possible in that process, rather than having to run the Kubernetes preflight checks to check some of those things when you're already partway through the install. So let's go back real quick to our install here and see what's going on. So we've got all three of our nodes joined, so I can continue with the install now. And this is going to proceed to just run through the rest of my install real quick. So while this is going, let's talk about the upgrade process a little bit too. So this is just going to upgrade my charts. So again, you can see my application has 3 different charts, and we're going to go through that upgrade process and upgrade those charts or install them, excuse me, one at a time. Now we'll briefly talk about the upgrade process. So for upgrade, I'm going to go back onto my first node here. And I'm going to download a newer version. So let's see here. Yeah. So this is going to be the latest version on my channel. So this is going to be newer than what I have installed in that demo there. And this will only take a sec. These bundles are not particularly big, so we're probably about 2/3 of the way done. But once this is done, I'll extract this and then show how the upgrade experience here is going to be very similar to my install process. Great. So what I'm going to do here, and I'll have to wait for that install to finish, but I'm just going to run upgrade and I'm going to pass it my license. And so this is going to be just like the install, but instead of installing, it's going to run me through a very similar UI and do an upgrade of all of my components, and it'll give me a chance to upgrade all of my nodes in that installation too. So this is almost finished, so we'll come back to the roadmap and then we'll finish up with that upgrade at the end here. Moving forward, so past kind of the customer requests in GA, we're looking to expand the install methods here. We talked about this a little bit in the last call, but the hope is that this installer would not just be for Linux, but also support Helm installs and existing cluster installs. So something that we've demoed to a lot of people that's gotten some really positive reception so far has been being able to use the config screen to generate Helm values for manual or GitOps-based installations that your customers do with the Helm CLI. And so in this case, you could run this UI, fill out the config, and when you're done, save it, and that would generate Helm values that you could actually pass to a Helm install. And similarly, expanding the same installer to support installing into existing clusters. So the same kind of process of filling out the config and installing those Helm charts into the cluster, but instead of us installing the cluster, we would use a kubeconfig that was provided as part of that install experience to install into that existing cluster. And then after that, enterprise depth is another area that we'd like to fill out a little bit more, install in more places and do it more easily. So we've had a lot of requests for ARM support over time. We've also had a lot of people installing on STIG and CIS hardened operating systems, and that is largely supported, but there's still a couple of things we could do to smooth out that experience. And so that's another thing that we'd like to add to allow this to go even further. And then lastly, I'll talk on migrations from existing products. So for curl, we're going to support in-place upgrades from curl to embedded cluster so that users can go through the normal embedded cluster upgrade experience and have that detect that there's a curl installation and export some info, stop curl, deploy embedded cluster, and then recreate all of your data and install the application to migrate you over from curl to embedded cluster in a process that feels hopefully less like a migration and more like an upgrade. And we're looking to help some people repackage their application or make whatever changes might be necessary to support this migration/upgrade. And then the same for COTS. So we're also considering supporting upgrades from COTS installations to this new installer so you can get this same experience for existing cluster as you can for embedded cluster and move those COTS customers over to that as well. So to round this out now, I'll come back over here and I've seen that my install finished, which is great. My Harbor registry is now accessible at the URL that I provided as part of that install experience. Now I'm going to run the upgrade. So run upgrade real quick. This is going to refresh that. Actually, I should quit the first UI there. All right, now this should bring me to the upgrade now. Yes, so now I'm on the upgrade. I'm able to change any of my configuration items that I input in the beginning if I want to. And then as part of the upgrade, we're going to run the host preflights. We're going to upgrade the runtime on the first node, give you some commands that are going to be similar to the join commands, but you're going to use those to upgrade the subsequent nodes. And then it'll just progress right through to upgrading all of our infrastructure components and then upgrading your application charts as well. So yeah, that's a quick demonstration of some of the multi-node capabilities we're adding, and we'd love for you to take a part of it. Like I said, we're getting really close to beta here, and so we've got documentation we can provide. So if anyone wants to try this out and give us some feedback and partner with us so we can fulfill some of your requests too, we would love that. So thank you.
Amazing. Alex, as you were doing your talk, I just kept thinking to myself about how this is a different company than a year ago. This is a different product and a different experience than a year ago. You flew through processes that even when using replicated services would take some time. So I just want to acknowledge how excited I am for everything that you're building.
Yeah, thank you, Kelly. We are too. I genuinely do feel like there's been so much great feedback from customers and things like that in the last year or so, and even beyond that with embedded cluster. And we've been able to harness a lot of that into a lot of improvements that I genuinely feel like we're just in such a great place with how embedded cluster is set up now to really be able to support a lot of other things that people are looking forward to in embedded cluster.
Yeah, absolutely. All right, that was our last talk. Thank you to everyone oh, we have a question. All right, a couple questions for you, Alex.
So the first question is about how let's see, the join command is generated from the COTS API. We won't be able to fetch that. So not necessarily via an API call to the existing install, but using the binary, you can still do that. So in some ways, it'll actually be easier because I assume what you're referencing here is like an undocumented COTS API that was subject to change and just worked for you. But now you'll just be able to use the existing binary that you've downloaded to generate the join bundle and copy that to the new node. So in some sense, it actually simplifies that and it'll actually be in a supported way rather than an undocumented API that could have changed at any time. And then let's see, second question is regarding upgrade paths. You mentioned that you're considering migration from existing COTS instances. By COTS, do you mean ECV2? No. So in this case, what I was talking about was we have customers that use COTS to install their application into existing Kubernetes clusters, so not embedded cluster at all. And so those customers would have the opportunity to upgrade those COTS installs to an existing cluster install that's managed by this installer rather than by COTS itself.